So let me tell you a little bit more about our programs, Environmental Engineering and Geological Engineering. They're both housed in the Department of Civil and Environmental Engineering at the University of Waterloo. I think you'll be surprised. They're not what most people think they are. So what I'd like to talk with you about today is our programs, what we have both in the classroom and outside of the classroom, because it's much more than just classroom study. We've got a co-op program. We have all sorts of fantastic departmental resources, and we're really interested in getting people to where they want to be after graduation. And again, that's a lot more places than you might be thinking of when you hear the words environmental engineering and geological engineering. Then I want to tell you a little bit more about some of our student experiences, and then ultimately tell you how to get in touch with us if you have any questions or you just want to learn more about what we're doing. So let's talk about the programs. So in the Department of Civil and Environmental Engineering, we have 4 programs, and I'm going to be speaking with you about 2 of them. One is environmental engineering and one is geological engineering. So environmental engineering, most people think of it as looking after things in the natural environment, but I like to think of it actually as how people interact with the environment they live in. And so that can actually be both the natural environment and the built environment and the interactions between those spaces and people. So in the program, we address issues such as the supply of clean water. Do we have enough? And is it of right quality? How do we treat it to make sure it's safe to drink? And it's not just water, it's also the air and the land that we live on. Is it safe to build on? Is it safe to breathe? What do we need to do with it to make sure that people can interact with the natural environment to the best extent possible for their comfort and their safety? And of course, as you can imagine, climate change, both mitigation of those impacts and adaptation, are massive issues that we necessarily have to undertake. Environmental engineers necessarily lead those discussions. And so when you think about engineering, every aspect of engineering needs an environmental engineer. And when it comes to the environment that we interact with, geological engineers are there to help guide us in assessing risks and how we interact with land that we build on and preserve, and also how we interact with resources that are found on that landscape. So for example, subsurface water supplies. And do we have enough? How do we interact with it? Can we preserve it and make sure that it's safe for all water values, ranging from ecosystem diversity to drinking water? So let's talk a little bit about the programs that you'll be having inside the classroom as environmental engineers. So you should see here, right off the bat, we have a term of coursework, and then we go into a term of practical experience in our co-op program. And that pretty much alternates throughout until we get into 4th year. You can see that we've got a lot of required technical courses, but also a wide range of complementary studies electives and tech electives that allow you to choose the paths that you want to specialize in, both with respect to your interests and also to the technical areas that you might want to specialize in. One of the things I'd like to point out with respect to our program is that you come for the fall term, and then immediately in January, you're already getting valuable working experience and getting paid for it. And we've done that on purpose. That's something that allows our environmental and actually our geological engineers, as well, as you'll see in a minute, get out into the workspace in January, get that valuable experience, and not be competing for jobs in the summertime when most university students are out looking for jobs. And so we see you back in the classroom, and it's actually fun to be in the classroom in the summertime because summer courses tend to be a little bit more relaxed, and that works really well with making sure that people get the most they can out of their educational experience. So when it comes to then those programs, I mentioned that there are different options for specializing with respect to both your technical program and then moving beyond your technical program. So in the environmental engineering program, we have areas that you can focus on, and we call those specializations. So as you can see here, they have a broad range. It can be energy, alternative energy sources, efficiency with energy, it can be green energy. It can be water supply, and that's what hydrology is. Hydrology is the study of water. We also have individuals here at the university who look at pollution treatment and control, and we're referring to that as pollution here because it can be water pollution, air pollution, and soil pollution. So we're looking at aspects of both when that pollution occurs, how do we clean it up, but also, again, when people interact with society, what can they do to make those interactions more positive, more environmentally friendly? You need environmental engineers to engage in those discussions because they're the ones that specialize in understanding those interactions and what we can do to not only mitigate, but keep interacting with our environment in a very sustainable way. That means we'll have access to those resources, not only now, but in the future as well. Our geological engineering program is very similar to the environmental engineering program with respect to its progression. So like the Enviro program, you see that we have alternating terms, starting off with a school term in the fall and then going on into co-op in the winter term, and then coming back to school for the spring term. So again, you're not competing for jobs when there's peak demand. And then what that actually allows you to do is when you go out for your second co-op term, you're going to be that much more competitive because you're going to be getting those jobs in your first co-op term that are highly sought after. You can see here again, we have the same progression between electives that are both complementary studies. So things like policy, things like economics, but then also technical electives that it might allow you to specialize in whatever area of interest you have that goes a little bit deeper than the overview of what is a geological engineer, what is an environmental engineer. And you can see that progression here. And I should point out that for both programs, fourth year, the terms are back to back. And one of the highlights of that is having a year long, or at least in this case, it's a 2/3 of a year long because it's 2 terms, a design project that spans across those terms that really highlights capacity and interest of our students. I'm going to talk about that in a little bit, so hang tight, we'll talk about that some more. In the geological program, we also have several specializations, and so they can range from geology, what are the materials that make up the landscape that we live on? So if you think about Canada, for example, we have a unique geology that even though we say we're very similar to our neighbors to the south in the US, our geology actually means that we have different risks relative to our neighbors, and they have to do with our history of glaciation. So our superficial materials are different when we're building, when we're thinking about water supplies, when we're thinking about hydrogeology, so that's the amount and quality of water in the subsurface, and our structures in general are natural infrastructure structures. So our soils, our rocks, how we can put built aspects of the environment on that landscape. We need to think about, is it safe? Are there going to be risks? And are those risks going to be exacerbated with naturally occurring disturbances that are exacerbated by climate change? So these include fires, floods. So we need to think about how we interact with that environment and sustainably survive in that environment and with our communities and with our interests in including, of course, being able to sustainably live on this planet. Now, we can further enrich our programs because, of course, we don't work in a vacuum. In environmental engineering and geological engineering, we necessarily are the department and the programs of I like math and science. Our science disciplines are our tools and our understanding, and math is the language with which we make decisions about science. So we have opportunities to strengthen or enrich our experiences in the undergraduate curriculum, depending on what areas of math and science you're interested in. So we've got some of those listed here for you. Certainly one of the ones that is on the forefront of many people's minds is artificial intelligence. We are now going into an age where machine learning and data-driven analytics are at a new level. We're going to need to think about how do we, as engineers, as applied scientists, make sure that the society that we live in really feels comfortable with these technology-driven solutions, that they feel that they can count on the decisions that are being made, not just by people, but by computers. It's going to be an interesting time, and as engineers, we take neither a dystopian nor a utopian attitude about that, but rather a science-driven perspective. And so really, we are going to be the leaders of the future, helping society decide how we make decisions. So this is an extremely exciting time to come into civil and environmental engineering department and work in either environmental or geological engineering programs. But it's not just limited to computers and math. We need to have subject matter expertise as well, because those programs are only as good as the information that goes into them. So you might be interested in management philosophies and strategies, or you might be interested in the life sciences and connections to health. You might be interested in how do we put together the software that's going to make these decisions? How do we quantify these decisions and risks? So you might be interested in statistics, for example. all of these options are here at the University of Waterloo with world-class experts that you can connect with so that you can be making decisions and making them based on the best available science and math approaches to those decisions. And so this is engineering. It's an evolving field, and it necessarily means we have to be able to work with others from other disciplines. Now, in terms of our classes, this is an area where you might be a little bit surprised. Yes, the University of Waterloo is a very large university, and our Faculty of Engineering is world-class, and it's very large. However, that doesn't mean that students become numbers here. So we have a very targeted and focused strategy with respect to what we expect from students and how we want to interact with them. So in the classroom, as you might expect, there's typically a good number of hours in the classroom. Classroom expectations typically range from about 20 to 25 hours per week, depending on the term and the specific classes you're taking, of course. But the difference between high school and university is a straightforward one. There's in-classroom learning, and there's also outside of the classroom learning. One of our goals is that you will become lifelong learners. How do we go about that? Well, there's a whole lot of enrichment that occurs outside of the classroom. And that might be in the form of lab time. It might be in the form of non-structured time. You'll find at the University of Waterloo, there are a lot of study groups and various opportunities to work in that non-structured time. And I'm going to talk about that in a minute. But I just want to summarize that overall, as an undergraduate student who's a full-time student, you're pretty much working a full-time job, and that job is 40 to 50 hours a week. So there's the classroom time, there's an equal amount of outside of the classroom time, and really that's true for most university. We do have a good deal of hands-on time in labs, whether they be design labs or science labs. And then also we have other formats for evaluation, and so I want to talk a little bit about those. So in our programs now specifically, so this is in environmental engineering and geological engineering, I think you'll be surprised to find that you're really not a number. I always think about how amazing it is that I remember students from 15 and 20 years ago, and a big part of that is our philosophy of education. We necessarily keep our classes small. Let me tell you, if you get into our program, it's because we want you and you belong here. We have small class sizes, they're very competitive, anywhere from 30 to 80 students between the environmental and geological engineering programs. As demand increases, because it's one of the fastest growing sectors in engineering for jobs, we might increase those programs in size a little bit, but we certainly won't increase them a lot. And part of the reason for that is we have a commitment to open door policy approaches. We want to interact with the students and get to know them, and make sure that they're advancing not only in their academic career, but also in their personal aspirations for their professional development more broadly. So connecting with various aspects of industry, for example. So consistent with that open door policy is trying to advance your whole growth as a student and as a professional, not just whatever might be occurring in any one class. And so that means getting to know you and being able to live up to our retention to, once you get in here, we want you to stay here. We want to help you in whatever it takes, recognizing that it's a big transition from being in high school to being in university. We just talked about how it's a different style of learning, but there are also other challenges that you face, and it has to do with learning how to interview for jobs, being able to provide you with feedback on your resume, being able to help you advance your interests. So we have all sorts of supports in place where we can interact with people, but it starts with an open door policy. We have opportunities to explore research, undergraduate research opportunities, the URA program. We have opportunities to support you in your co-op placements. So connecting with employers, both while you're looking for employment and when you're not. And you'll hear about that some more, but we have wonderfully high placements, almost entire placements every class. And of course, then there's the professional development. So it doesn't matter how brilliant you are. If you can't communicate that brilliance, then that's not going to get you very far with respect to development in your career, and also with respect to development and impacting the world you live in and the world around you. So communication is a huge part of what we do. Communicating your ideas, communicating that brilliance, communicating the ideas of groups, because multiple heads are better than one with respect to solving the big problems of today, the wicked challenges that we are faced with, the wicked problems of things like climate change adaptation. So how can we maximize the impact of the science and math that we are learning? That's what it comes down to. And so how do we make that happen with respect to departmental resources and the curriculum? We've got industry leaders, we've got academic experts, and all of them bring that experience and expertise to bear inside of the classroom. One of the really neat and special things about the University of Waterloo's Department of Civil and Environmental Engineering is that we have a dedicated first-year teaching team. These are people who have won awards for teaching, and they're not just here to teach you in the classroom. They study learning and teaching styles, problem solving. They're here to help you manage your time, to transition from high school to university. We also have specialized TAs who are students who are just a few years ahead of you that will also help you in the classroom with respect to managing your courses and your time, because they've been there. They can help you study, they can help you prioritize your deliverables, and they can also help you communicate not only with each other, but with your instructors and with the administration to make sure that the program is advancing in a way that allows you to put your best foot forward. Because that's what we want. We want everybody to do well, and if that means changing things, communicating, and with how we interact, that's what we're committed to doing. It's a team effort here, and it's an open door team effort. So anything that's going to help make the learning experience better all around. And part of that also then comes from how we interact with each other outside of the classroom. We have a lot of award-winning student societies here. We're really proud of KEGS, which is the Civil, Environmental, Architectural, and Geological Engineering Students Group. They're a perfect example of how we have these different programs in different disciplines, but they all fall under the same umbrella, and they're all charged with the same general mandate, which is sustainable leadership in the built environment and the natural environment, and how people interact with both of those environments. So whether they be technical experts or other members of society that aren't in those technical positions, we then bring those people together, and those student groups, the faculty get involved in things like, how do I interview? How do I put together a good resume? Can you critique my resume for me? I'm really interested in this topic, and it's not something we covered in class. We have guest lectures that come in to talk about those topics. We have field trips, tours, etc. And of course, we're also very much committed to people's wellness, making sure that you know you're a person first. Your health has to come first and foremost. And yes, there's the academic program, but it'll always be here. So let's make sure that you pursue it with putting your best foot forward and making sure that you're in the best place possible to continue down that academic path now, and then also when you leave here. One of the things Waterloo is really well known for, that probably isn't a surprise, is co-op. So let's talk a little bit about co-op. We talked a little bit about co-op with respect to advancing through the program and how we pretty much alternate every other term, academic term in the classroom, then experiential term out in co-op. And the progression here of sequence is provided. But one of the things I wanted to point out on this progression is you can see here, we have a really high co-op placement rate. It ranges here on this particular slide anywhere from about 93.7% to pretty much full placement at 99.5%. Employers seek out our co-op students because of their capacity. There's no question about that. The reason probably why our numbers aren't right at 100% is because we have students that also go on their own terms with respect to opportunities, for example, for international study abroad, or they take leaves to pursue a competition, for example. And so they step away from a co-op term. We do have in our program a large number of required co-op terms. There are 5 required co-op terms, but you can have a 6th term where you may be on co-op or you may be doing something else. But regardless, as you can see from first year all the way through the final year, we have great placements, and we get paid very well as co-op students. You might have heard that students sometimes graduate from Waterloo with occasionally no debt, but probably more realistically, a little bit of debt. But as you can see by our average salaries or earnings for 2019 in engineering, our students tend to do well. So it allows us to think about how we want to manage those debts and perhaps contribute to our education and the cost of that education. So students do pretty well with co-op. It's a great program, and to boot, you get experiences that will help you decide not only what you do want to do, but equally importantly, what you don't want to do. So when it comes to those real world opportunities, you name it, people have those types of opportunities. Private sector, consulting, industry, public sector, government decision making. It could be regulatory government, but it also could be things like municipal government, or even globally, positions with groups such as the United Nations. Really depends on what you're interested in. Some people take research positions, on campus, off campus. The positions might be focused on the technology aspects of environmental or geological engineering, or they might be focused on the landscape aspects, the natural infrastructure or environment that we're dealing with. One of the things I like to often talk about is I see it all as infrastructure. Some of it's natural resource based, some of it is built, but it's all infrastructure that we're dealing with, and we're really negotiating how we interact with all of that infrastructure to maximize our goals and maximize benefit for society. But regardless of the types of interactions you have, the good news is that all of those experiences count towards professional designation. So PEng licenses, co-op counts as 1 year out of 4 for your professional engineering licensure. There's a whole range of jobs in co-op. I've got some of them listed here and you can read them, again, ranging from industry, government, research. And one thing I'll point out is that you can also be on campus as a TA. So WEEP is the Waterloo Engineering Endowment Fund. And we have TAs. Those are those TAs I was referring to that help out first year students. Those are second, third, fourth year students that are there to help share their experiences with you. And they're giving back to the program because they want students to excel just like they benefited from other students who helped them excel. So there's a neat range of opportunities that you can have. And not only is that true in environmental engineering, it's also true in geological engineering. Some of them are more discipline specific, but there's also those broader opportunities, environmental, civil consulting firms, the WEEF TAs, et cetera. So a really neat range of opportunities, and you could never capture all of that on a slide. One of the big challenges that people ask us about is first year, what can you do? Part-time summer jobs, extracurriculars. We really help you get there with, in addition to having those experiences, giving you very specific experiences like surveying, AutoCAD, technical writing in first year, in the first term, so that when you go out for that job, you're competitive. And not only do we do that from a classroom side of things, but we also do it from a professional development side of things. So technical writing experience falls in there, but also resume critiques and mock interviews. Those come from both your professors and also a lot of the clubs, the student-run clubs we have on campus. And so hopefully, I'd like to think, but I think our students think overall this leads to some pretty positive student experiences. So with over 250 clubs and societies, a lot of faculty, so engineering, faculty of engineering focused events, and then university-wide events, whether they be intramurals, varsity teams, just clubs, fitness clubs, and also residences that have their own activities. There is a whole lot to do here. And I think if you talk to any UW engineering student, and that really goes for any discipline in engineering, but certainly in the programs we're talking about here, there's time for that. We want you to have time. If there's not time for you to have a life outside of school, that means we're doing something wrong, because we're interested in people developing as whole individuals, not just as the narrow technical civil engineer, environmental engineer, architectural engineer, geological engineer. We're a group, family style education, open door policy, and we're committed to everybody progressing in areas that interest them. And so if these are the kinds of things you're interested in, developing solutions, solving problems, and affecting both the natural and built environment and how people interact with it, you belong in environmental or geological engineering, because you will get that expertise and the ability to focus your direction more as to how you can tackle these challenges moving forward. So join us in changing the world. Check us out. We'd be very, very happy to follow up with you. We look forward to hearing from you. Take care.